Thank you very much. It's a pleasure to be here. I live up in Blackpool, so it's really nice to be in London for the day, although it's a couple of degrees warmer than it is up north. I wanted to present today one of my books. I've been an author for a few years now, but this is quite a fun one because it brings together two of my passions, which are science and music. That is supposed to be me on the front. I've worked with the illustrator Liz Kay for a few years now, and she was very, I didn't ask for it, but I'm very happy that she's drawn me there, playing the saxophone on the moon. So before we start, this talk is called Can You Get Music on the Moon? And I'd like to do a little poll to see if you think you can or if you think you can't. So if you think you can get music on the moon, I want you to shout music. And if you think you can't get music on the moon, I want you to shout no, all at the same time, and I'm going to see which one is winning. On the count of 3, 1, 2, 3. Okay, I feel like that was relatively half and half. We will come back to that in a little while. Okay, so a little bit about me. So I've been in love with science since I was quite little. I fell in love particularly with space when I was about 13, and I have followed various different careers all based in the space industry since then. So planetary scientist, space educator, teacher, author, etc. So much so that sometimes I feel like a little bit of a jack of all trades or a Jill of all skills, which I've heard recently, which I quite liked. I get called strange things like Miss or Dad sometimes in school. I'm definitely not anybody's dad. I am a mum, though, a proud mum as well. My love of science started when I was quite little. This is me dressed as a robot, age 6. I was lucky. I came from a very high science capital background. My parents are pharmacists. My sister's a GP and works for the NHS. That's her dressed as Minnie Mouse, by the way. So I love science ever since I was little. I did start off wanting to be a vet, but then I saw the film Apollo 13. Has anyone else seen it? Quite a few times. A very young-looking Tom Hanks there. So Apollo 13 was based on a real, although ill-fated, mission to the moon, where the astronauts had to work together to survive and come home safely, which they did. And even though it was a disaster film, essentially, I came out of the cinema and I thought, I want to go into space, and I became obsessed with astronauts and space from that point. It was back before the internet really existed, so I went to my library and read about astronauts and read about Helen Sharman, the first British astronaut who had a PhD in chemistry, and read about Michael Foale, a half British, half American astronaut who had a PhD in astrophysics. And so at age 13, I was like, right, I'm going to do a PhD in astrophysics. I didn't know what a PhD was. I didn't know what astrophysics was at the time, but I did follow that path. I thought the academic path was for me. So my PhD and my postdoc career was with the Cassini team. So Cassini was a flagship mission to Saturn in the 1990s and 2000s. It spent about 14 years at Saturn before being deorbited in Saturn's atmosphere where it burnt up. And the team were a huge global international team of scientists literally across the world. And it was really quite a spectacular mission. And I could talk about Cassini and Saturn for days. There is still data to be analysed by the Cassini spacecraft, even though it burned up in 2017. So the youngsters, and not necessarily the youngsters among us, if you're interested in doing your own research about Cassini, there is still data there to look at. During that time, I realised that as much as I love doing science, I also love talking about science, and I went into space education and teaching. And then I sort of fell into writing books, which has been fantastic. I have 15 children's non-fiction and 1 adult non-fiction out about space, but also about science and nature, about women in history, about all kinds of things, really. My next one coming out in September is called, it's got a very snappy title. It's called The 10 Extraordinary Ideas That Shaped our understanding of the universe. I think that's it. I get it wrong all the time. It is a kid's book. It's basically a physics textbook. I tend to call it 10 Ideas for short, but that comes out in September, so keep an eye out for that one. So today we're going to be talking about whether or not you can get music on the moon, but we need to learn about sound to start with and how sound is produced. Sound is fantastic. We've got light and we've got the electromagnetic spectrum, and all of these things are waves, and sound is a wave as well. It's a longitudinal wave rather than a transverse wave like light, but it's a way of transferring energy, and it's a type of energy that is created when objects vibrate. So, you know, I knock on this lectern, the particles in the lectern vibrate, they bash against each other, they cause a chain of vibrations, then that vibrates the air that vibrates towards my ear, and then stuff happens in my ear, which I'll come to in a minute, causing a chain of vibrations that eventually gets heard by my brain as sound. And it's really, really clever, because that means that you can hear sound, but you can also feel sound, and you can do some neat tricks with sound as well. There's various bits of the wave that we need to know if we're trying to understand sound better. So amplitude is the height of the wave. The greater the amplitude, the louder the sound. And then the wavelength goes from the peak to the peak, or the trough to the trough. And the shorter the wavelength, so the more waves are in that short space of time, the higher the pitch. So the really squeaky sounds, because the particles are vibrating so quickly. So the difference between a mouse squeak and a lion roar is to do with the amplitude and the wavelength. Now, because it's all to do with vibrations, we need stuff to vibrate in order for sound to travel. So sound needs a medium, or particles, to travel in, and that means in a vacuum, when you suck all the particles out, there is no sound. And there is that famous moniker, in space, no one can hear you scream. So that also means that sound travels differently in different materials. So for example, in a solid, there's a lot more particles, so the particles can vibrate more, and that means that the sound travels faster. And there are fewer particles in air, and because of how tightly packed they are or not packed, the sound actually travels slower in air. And you can do all kinds of neat experiments, but just to show you that sound is a vibration, I brought a tuning fork along with me, and it tells you what note it is and what frequency it is. So this is 440 hertz and the note A. And what you do is you just make it vibrate, and by making it vibrate, you end up with the sound. So I'll try not to ruin anything in the Royal Society, but don't tell anyone if I do. I'm left-handed, so I'll bang it this way. So I'll bang it a bit harder. So you can just about hear the sound A there. And you can get tuning forks in different shape, well, same shape, different sizes, and different length tines and things like that to get the different sounds, the different notes that we know of. So how do we hear? Before I just said stuff happens in your ear, but stuff does happen. Does anybody know what this bit of your ear is called? The flappy bit. It is the pinna, thank you. Lots of people don't know, but it's almost obsolete. Well, it's not, it's useful, but we don't need it to hear. What it does is act like a funnel to channel all those vibrations into our ear. So some animals don't have flappy ears, some do, but they can still hear depending on the mechanisms. But the pinna acts like a funnel to collect all the vibrations. It's also great to decorate with, you know, getting your ears pierced and the rest of it. The vibrating air particles reach inside into our ears once they're funneled in, just like I said, into the ear canal, and then the vibrations bounce around and amplify. So you're causing the sound to get bigger and bigger and bigger, and then eventually they bash against the eardrum. The eardrum works just like the skin of a drum. It vibrates more. The amplitude makes the drum vibrate more and more and more. The vibrations carry on through to 3 small bones in the inner ear, which vibrate even more. And then they get to the vibrations get to the cochlea, which is this snail-shaped part of your ear that is full of these tiny hairs, and the vibrations and the sound waves cause the hairs to vibrate even more, and then eventually those vibrations are transferred as electrical signals up to your brain, and then your brain translates them into sound. And I just think that is absolutely fascinating. It's so clever, whoever designed it, however it was created, because of the way it works. It's just fascinating. It also means, because it all works with vibrations, you can bypass the bit of the inner ear and have cochlear implants and listen directly into your brain as well, which is, again, such a feat of engineering. This is quite a fun little trick that you can do at home to sort of see how your ears listen. All you need is a piece of string and some spoons or some forks or anything sort of metallic. What you do is you vibrate the spoons against each other. The vibrations cause the string to vibrate, and that transfers the sound. Then if you wrap the string around your fingers and just hold it against your ear, the vibrations are amplified, and you have an orchestra going on in your brain. You can't hear anything else except for this sort of amazing echoey chimes of these wonderful spoons. So do try that one at home, or if there's time at the end, maybe someone can have a go themselves. But just a really simple demonstration of how sound travels. You could also do the paper cup telephones and rice vibrating on a speaker and all sorts of fun things. Okay. So sound isn't just how it's made, musical instruments, etc. It's also communication. So we're going to have a little look at how animals communicate in different languages. We've got 4 animals on here. We've got a dog, a horse, a cockerel, and a pig. Well, I'd like you to make the noise of the animal, if you don't mind, when I say the animal. So, dog, first of all. Woof, woof. Okay, brilliant. Horse. I like this, yeah. Pig. Excellent. And then the rooster or the cockerel. Okay, fantastic. So now I'm going to ask you what animal you think is making the noise, but I'm going to say the noise in different languages. So those are all the English ways of these animals communicating for us, right? Okay, what do you think, which animal do you think is saying Sahil, Sahil? Okay. The Sahil is actually the horse. So that is Lithuanian. Groin, groin. Okay, very definite pig there. Yeah, so pigs say groin, groin in French, that one. They say rough, rough in Hungarian. So that's quite fun. Okay, only 2 left. So quick query, quick query, quick query. Is a cockerel, and that's Spanish. In Chinese, they say goo, goo, goo. And then, last but not least, wang, wang has to be, of course, the dog, and that is in Chinese. So it's fascinating that we have all these words for how these animals communicate, but they are translational and work in different languages as well. Keeping on the animal theme, did you know that the howler monkey is the loudest monkey on the planet? So it has a special hollow bone in its throat, which massively amplifies their sound, giving it that special accolade of the loudest monkey on the planet. Has anyone heard a howler monkey before? It is quite a fascinating sound. It's really sort of guttural and low, and that means they can communicate across vast distances. So sound is brilliant for music and for communicating, but it can also be extremely powerful. What scientists have done is have used the vibrations of sound and ramped them up a bit, and actually been able to do something called acoustic levitation. So using the vibrations of sound to levitate things, which means float above the ground. And this can be done with things like magnets as well, but you can levitate objects by using sound. So what scientists do is use these really impressive speakers to play sounds at very, very high frequencies, much higher higher than humans can hear, and that means the vibrations are really, really powerful, and they have so far been able to levitate objects like fish. Don't know why they have decided to levitate fish, but they have. And they can also use these vibrations to conduct experiments in space. And that means that we can use sound to do things like knock stuff over. So I've got a paper cup here. I'll put it here. Now, if I shout at it, it's not going to move. Ah! Doesn't move at all, right? But if I amplify that with my vortex gun, it will hopefully fall off, and I'll try not to hit anyone in the front row. This works like a really fancy ear, basically. It's got this drum here, and if I put it out, it amplifies all the vibrations, and you are able to use the air that's coming out of that to do things like blow candles out and hopefully knock paper cups off of lecterns. So, shall we do a countdown? 3, 2, 1. Quite a good amount as well. So they're kind of fun, but that kind of explains how acoustic levitation would work in a laboratory. Okay, last but not least, can you get music on the moon? So, well, you'll have to buy the book to see, is the no. I will tell you, seeing as you've given up your time today to come and talk to me. So we've learnt a few things about sound. We've learnt that we need particles to vibrate in order to create sound. Outer space is a vacuum, so there are no particles, and in space nobody can hear you scream. So that's a no. Outer space is definitely a no. However, on the International Space Station, which is orbiting around the Earth around 400 kilometers up, astronauts have been living there since the 1990s. Not the same people, but they live up there for maybe 6 months, go down, and different ones come up. They obviously need air to live in. So air is pumped in so that they can breathe, which means that there are particles that can vibrate, so people can live, but can also communicate. And actually, the International Space Station is a really, really noisy place to live because there's fans on, there's air conditioning, there's people doing experiments and exercising, and they are allowed musical instruments in space. Astronauts are always allowed to take certain amount of personal items. So into space there has been a guitar, a saxophone, a flute, a didgeridoo. So there has been some good musical instruments up in space. But more specifically, the moon doesn't really have an atmosphere that we can kind of count on, so sound wouldn't really be able to travel very well. So technically, sadly, no, you can't get music on the moon. So that picture of me playing the saxophone on the moon and this alien rock band might look very cool, but as humans, we wouldn't be able to hear it. However, there have been astronauts that have heard or have reportedly heard strange sounds during the Apollo missions in the 1960s and 70s. Strange sounds were heard on the surface of the moon, but also as astronauts were in their spacecraft around the far side of the moon as well. And those sorts of sounds are still a bit of a mystery. There haven't been a huge amount of people up on the moon or around the moon. And maybe it was interference, maybe it was something going on in the spacecraft or in the helmet or something, but maybe it wasn't, we don't know. Luckily, we are in a new kind of lunar era where there are more people going back to the moon, so maybe we will find out with Artemis 4, or maybe some of the people in this room will be the next people to the moon, and you can listen out for some mysterious music on the moon. It might not be me playing the saxophone, although it would be quite cool if it was. I'd be like, hi. So I hope you've enjoyed that and learnt a little bit. Hopefully you can also see that I've had a really fantastic time working in the space industry. It's given me so many different opportunities, from traveling around the world to meeting incredible people to writing books as well. I did get to meet and work with Helen Sharman at one point. I also met my husband through my PhD, and we've got 2 lovely boys as well. So for those of you that haven't decided what you want to do with your life, and that's not necessarily the school children in the room, you can start at any point. Just remember that space is amazing. It really is for everyone. If you're proactive, space can help you in ways that you really didn't expect, and the sky isn't the limit of what you can achieve, it's just the beginning. Thank you very much. Okay, there is time for questions, or if you want to try.
Thanks for the talk. So to go back to the other picture you had with the aliens playing in their rock band, if that alien were playing the drums loudly, you were standing a few meters away in his spacesuit, could you possibly get sound transmitted through the vibrations in the ground?
Yeah, so you could feel vibrations. So when I taught in high school, and there was a whole module on sound, and the children, two of the children in my class were hearing impaired. One was completely deaf, and I was worried that he wouldn't be able to access a lot of the resources. But instead of, well, we did the PowerPoint presentation and the talking as well, but we did a lot around vibrations, and we, instead of showing him things, we get him, and everyone actually, to shut their eyes and feel the vibrations. So as long as the vibrations are strong enough, you would, in theory, be able to hear them, but you'd probably need a very big drum kit.